Welcome, welcome, everybody. It is build day, and it is literally a big build day. We are building the Boston 120% keyboard. This is the 3D printed R1 kit from R&D KBD. As with all keyboards, the PCB of this board is really the meat and potatoes of it. But R&D did a run of these where they did all the 3D printing and everything for you. I will once again point out that, 6 feet that way, I've got a 3D printer that is currently just holding mods for my 3D printer. It's one of those long-term projects that I don't have time for at the moment. R&D KBD sourced the plate, the components, they printed the parts, they got the PCBs together. I think JLC did the actual production of the PCBs. And it is all here in a box now for me to put together. What makes it 120%, you might ask? Well, 100% keyboard is, alpha, nav, numpad, function row. This has a second function row on it. So about 20 keys more. How about that? Yeah, and we're gonna go through this today. This is the box full of parts you get. I have already done some work on the parts in this box. As much as I want to show everything in my videos, this would be a ridiculously long video. I'll get to explaining why in just a minute here as we're going through the parts list. So I've already done a little bit of prep work on some of these parts to make this video as smooth and enjoyable as possible. It's still going to be long, probably, because this is a big, weird keyboard, and I'm really excited to build it. But all that to say, this is not exactly as these parts come. So first things first, a fat sticker with a QR code for the build guide, which I have open off screen as usual. But if you want to take a look at it yourself, you can scan this QR code with your phone's camera, and it'll open up on Blue Pylon's GitHub, which is also linked down in the description. Very good build guide, very in detail build guide, 35 pages, mostly because there's a lot of pictures. It's not 35 pages of just text, there's a lot of images, which is nice. This is specifically the build guide for the 3D printed version. I believe Blue Pylon. I cannot talk today. This is the 6th take of this intro I've done. I believe Blue Pylon is working on a metal version of the Boston. This is the 3D printed plastic version. So obviously the build guide's quite different, and I think this is constructed in a really cool way. I've read through the build guide already, and it's quite cool. As with any build guide and any video, we should start with parts. So I'm going to get this out of the way, actually, because that is a very big box. We're going to start with our little bits and bobs bag. You'll notice my screw kit is ticked rainbow. There are 2 different sets of case fasteners from this GB, and I wanted the rainbow ones because I think they're pretty. So it comes with as it has 2 function rows, it also has 2 escape key positions. So the top escape key position is actually a rotary encoder. It comes with a very nice, actually, 3D printed knob. This kit does from R&D KBD. I went ahead and actually ordered online some rainbow metallic guitar knobs that I'm hoping will match the rainbow metallic finish on the screws. So you just need a knob, R&D 3D printed and included with this kit. I went out of my way to get different ones to use. So we got that. These are rather interesting. These are pieces of FR4 that are the feet holders. They're basically these little spacers that go on the bottom. So you'll see when we get there. But these are what the feet assembly goes into. This is one of many 3D printed pieces in this keyboard. This is a little spacer that holds the status LEDs for cap, scroll, and numlock. And then also you can see the little notch here and the hole here. The associated resistors with those LEDs fit into this piece quite nicely. So this is a little alignment jig, which I think is quite clever. Hardware-wise, this is the bag that has our rainbow case screws in it. So you can kind of see those, as well as some non-rainbow screws that are used in other places in the keyboard. So we got those bad boys. We've got some M3 Torx head of a shorter length here. I'm not fully sure where all these go, but yeah. PEM nuts. So what a PEM nut is, I'll hold the bag here so you can see the label as well. PEM nuts are used in situations with like sheet metal where you're embedding a nut in something that you can't tap threads into. Those are part of the plate assembly. So when we get down the parts list to the plate, I'll reveal why. I'm supposed to have 11 of these PEM nuts according to the bag, but there's only one in there. Yeah, so we'll get to that. Speaking of the LEDs and resistors for the indicator lights, there's those bad boys. Our knob, rotary encoder rather, and our feets are in this bag right here. Some hex nuts, these are involved with case assembly, I believe. And some self-tapping M2 screws. These will come up in regards to the plate assembly as well. And then they have gone ahead and included 2 hex keys and a Torx key. Here I've got ones that I quite like. I've got my Rama Torx keys here, and if I need hex keys, I've got my usual rainbow ones on call. So those are all of our tiny little bits and pieces within the kit here. I'm just going to tuck those back in the bag for the moment. There's going to be a lot of parts shuffling today. I can already feel it. And then what remains in the box? So we've got, let's start with the case. The case, you hear 120% keyboard and you think it's going to be huge. It's actually not that big because it's the compact version, so there's no nav cluster that fully separates the numpad and alphas. It's actually kind of like the LCK here, how there's just a single nav column and then kind of arrow keys that are down and out of the way. So when you have, I went for the sparkle black finish, by the way, so it's black PLA with glitter within the filament. So as it prints, come on camera. I know there's lots of interesting stuff in the background, but I need you to focus. Buddy, there we go. So there's this nice sparkly finish within the plastic. But it is big enough that it's printed in 2 pieces, is where I was going with that. So there's they meet in the middle as such. So really the keyboard itself isn't enormous because of how nice and compact the layout is. So I'm sure if you had a big enough 3D printer, you can maybe print this as one piece, but then you're getting into support material. These are designed to print like this, standing upright, so there's no overhangs anywhere, and you can print them without support material, which is very clever. That's good design from Blue Pylon's standpoint, assuming they did the case. Actually, I don't know if they designed the case as well. And then these 2 weird pieces. This is where assembly for this board gets kind of strange. So I'm gonna pretend those are together like that. These are spacers, actually. So these screw on to the plate. The plate goes into here, and then they end up in the right positions. So you have kind of one here that's outlining the knob and the F-row and all that. And then you've got this one here doing the same thing, but also outlining the arrow key. So these actually screw onto the plate. So the order of operations of this board is really quite interesting. So should be a fun build. I've been looking forward to this one since I got the kit. But as it is such an enormous keyboard, I had to do quite a bit of prep on like switches and things. But we'll get there. Stand by. This goes on the back of the keyboard. This is a piece of FR4. The astute among you will notice this is a map of Boston, hence the name of the keyboard. Just a really beautiful use of the solder mask on the back of the FR4 here. Really, really lovely. So that'll be a cool back piece. And now we're getting into the pieces I've actually done some work on. So let me once again kind of reshuffle here. The plate. So this kind of gives you an idea for the layout of the keyboard. My hand is kind of under the alpha cluster here. There's a little 3-key 1-column nav cluster, arrow keys, numpad goes here, and then your 2 function rows and your knob and power LED are up here. So now the work I did on these, the PEM nuts. You can see right there along the top edge, that is one of those PEM nuts. So you actually solder the PEM nuts to the plate. I'll pull the one PEM nut, the extra one, out here so I can kind of show you how that works. Typically with PEM nuts, you press them like with force into something like sheet metal. But in this, oh boy, dropping small parts. But in this case, you see how the side pointer at the top of the screen is just a little smaller than the bottom? That slightly smaller part is knurled or ribbed and kind of bites in. The hole in the plate is just a little undersized, so you kind of press it in and then you solder it just like any other component. So the way I found that worked well for this, if you're using this as sort of an ad hoc build guide, is number one, I cranked the temperature on my soldering iron way up. I solder at 325 Celsius. I just cranked it up to 480 all the way because there's so much thermal mass here. So what I did was I came up against the right side, just because I solder right-handed, pressed the soldering iron against the metal pad on the plate and the metal nut, flowed just a little bit of solder between the two to kind of create a good heat conduit. And then when I saw the solder creep over to the other side through the wicking action that happens with solder, I added a little bit more to this side because I knew then that this side of the nut was hot enough to melt solder. So I did that for all the positions here along the edges of the plate, and that worked out really well. They are very solidly in there. I think it's a really clever way of doing that because, you know, anything else you would need to have like a nut on the top side that you threaded, you know, a spacer into or something. Whereas this, you're losing no Z height except for the amount that the nut sticks out because, you know, the threads need to exist. And you get a threaded point in an FR4 piece. So brilliant design. I think that's very cool. So that was one of the things I did off camera, was soldering in those bad boys. So there you go. Those do not come soldered in. And future versions of this kit might be built completely differently. So that's why I'll link to the GitHub down below so that when and if you are building one of these, if you're just watching this for entertainment, thank you for watching. If you're watching this as a guide of sorts, I would highly recommend checking out the GitHub for the most up-to-date stuff. And then, so the last piece here is the PCB. Now, the PCB, I am almost certain, is the most expensive part of this keyboard by a long shot. I was not particularly interested in soldering in all these switches and then finding out I didn't like the switches or I wanted to change them or something. So for the first time ever, I Mil-Maxed a PCB. Now, if you're wondering what Mil-Max is, Mil-Max is a company. These are Mil-Max sockets. These little like sub-grain of rice sized cylinders. One end of that cylinder has a flare, like a flared top on it. And the cylinders are hollow with little fangs in them. So basically what that gets you, I'm gonna zoom in here, but these are so small. Mil-Maxing. So you can see, we're gonna use that as an example right there because my finger found it. The bottom of the cylinder is sticking out through there and you can kind of see into the bottom. There's like little teeth, kind of a little starburst shape in there. And then on the top is where the flared head is and sits almost flush against the PCB. There's a couple sizes of these. The ones I got are the ones that sit darn near flush on the top of the PCB. Not quite flush, but darn near. And what that allows you to do is basically turn a PCB that is designed for soldering, such as this one, into a hot swap PCB. Now, do I think using this PCB as your first time Mil-Maxing is smart? No, not necessarily, but if you're a good solderer, like I am, or I believe I am, it's not terribly hard, it's just long. So earlier when I said I don't want this video to be a million years long, because it could be, I was referencing that I've obviously already filmed this segment where I Mil-Max the PCB. I am sitting here just a couple days, or I think a week maybe, removed from doing that. That footage alone is 2.5 hours. Now, I edit these way down. I time-lapse through a lot of stuff. I cut through a lot of stuff. They're still about an hour long for a normal keyboard, but these are, you know, these videos are way cut down from how long they actually take to film. So, the following... Well, let me finish the parts list here. Plate, back, feet, bump-ons, LEDs, resistors, knob, screws, PEM nuts, normal nuts, self-tapping screws. The things you need to supply, of course. I'm using lubed and filmed Zaku switches. These are made by Texi, sold by Bolsa. They are a long pole, long spring linear that I quite like. I initially built my Rami U80 with them and fell in love with them there, and I've bought quite a few more, enough for quite a few more keyboards since. So you need to supply your own switches. There's a number of different splits and things you can do. My layout, I think, requires 125 switches, but you need as many as 127, depending what all things you split or don't split. Is that right? Well, that's what the guide says. +2. Yeah, that seems about right. I lubed and filmed 130 switches, just to be safe. You need to supply keycaps. Now, obviously, not a lot of keycap sets come with a second F row. I will be using Laser by GMK today, because I've got enough novelties in this set that I can fill out that second F row. And honestly, I think it'll look kind of nice with the rainbow hardware and the black sparkle PLA. Full disclosure, someone in a Discord server I'm in already built a sparkle black Boston with Laser. So kind of a bummer that I didn't beat them to it, but I do know that it looks nice. So I guess that's an upside. So you'll need switches, you will need keycaps that cover it. Obviously, with things like GMK Relegendables running last year, once those ship, that opens up your possibilities a lot. You can use blanks, follow your heart for that top F row. If you're the kind of person that is using a keyboard with 2 F rows, you probably don't need to know via a legend what those top 20, almost 12, 18, what those top 18 switches do. You need stabilizers. I am using Durock V2 stabilizers, Krytox 205 grade 0 on the plastic on plastic interfaces, Krytox XHT BDZ on the wires, pretty typical. I did use TX stabs for the first time this morning. I did a minor rebuild on my Mode 65, the polycarbonate one. And I really like TX stabs, so I'm hoping those become more available so I can use them more often. But today, at least, I already bought Durock stabilizers, and it is way more than normal, because I'm usually a TKL or 65 guy, whereas today I've got a numpad to deal with, so I've got a whole extra 3 stabs here to contend with. USB-C cable, got it. Knob, got it, already talked about it. And optionally, you can actually solder in per key backlighting on this, because obviously I want this keyboard to be hot swap. I'm not soldering in LEDs. That completely defeats the purpose. But that is another thing you can do. And then they do recommend the tools that you need. 3D printer. Someone printed my parts for me, so no worries there. A T6 and a T10 Torx key, soldering iron, obviously. Super glue and thread locker, I think are optional. I have both. I think they're optional. And then they recommend having desoldering equipment if you need it. So that's a quick rundown of all of our parts. The next segment you see is going to be the part I already recorded, where I go through the process of mil-maxing this, learning how to mil-max. I really screwed up down here, so I'll definitely have that part in. I'm not yet sure how I'm going to edit that, because again, it's 2.5 hours of soldering. So yeah, not the most thrilling watch, but I will edit some amount of that in. And then I've got a bit of a preamble in there about why I'm mil-maxing as well, and I just kind of said some of that here. So the edit remains to be seen. But the next segment you see will be me mil-maxing this PCB that I've actually already mil-maxed. So I will see you on the other side of that. Hi everyone, Ian from the past. This is the soldering segment of the Boston 120% keyboard build. I've tested the PCB, plugging it in with a pair of tweezers. Always test your PCB, especially when there's this many possible points of failure within it. Fun fact, this contains about as many switches as 265% keyboards, because you see you got your alphas, your numpad, 2 function rows, a tiny little nav cluster, and your arrows. It's quite the layout. But I'm doing this first because I'm trying something new. And if past Ian for you, future Ian for me, has already explained what I'm doing uniquely with this build, I'll try and edit around it as cleverly as possible, or you'll just listen to me say the same thing twice. I am mil-maxing a PCB for the first time. If you're not familiar with mil-max sockets, they are these little cylindrical sockets that go into the holes on PCBs to make parts that aren't socketable. So before mechanical keyboards ruined the internet, they were used for things like microcontrollers, components that needed to be swapped out frequently, that kind of thing. Now, if you Google Milmax socket, and I just did, it's just pages upon pages of keyboard vendors selling Milmax sockets, these little cylindrical guys. So I'm Milmaxing my first PCB, and I pick a PCB that has like 130 switches in it, 129 at the max, I think. But, you know, go bigger or go home, am I right? And it should be more clear. This isn't technically the first time I've Milmaxed a PCB. One of my macro pads that I ended up not liking very much and not using very often, I'm not going to name drop it because it's a fine macro pad, it's just not for me, was Milmaxed, both for the Elite C controller and for the switches. So I have done this before, just not nearly at this scale. I have, in fact, never built a keyboard at this scale before. So, yeah, I assume that this is going to be mostly a huge time lapse of me doing this. My 128 gigabyte SD cards that are in my cameras hold just shy of 3 hours of footage. I'm really hoping I can get this done on a single SD card, he says in the middle of a long, probably needless preamble, but I assume you're coming here for the personality. I hope I can get this done within one SD card worth of work. If it is over that, I probably just won't film the end of it. I don't want to deal with that much footage for what is effectively the same thing 130 times. But what I do want to make sure I film is me doing it the first couple times, both as possibly an educational experience for y'all watching, and if I mess up, it's probably going to be in the first couple that I do, because like with soldering actual key switches in, you really kind of get into a groove with this stuff, and you do anything 130 times, you're kind of going to get into a groove with it. So there's a couple schools of thought on how to put these in. Some people will slip these over the legs of a switch and then put the switch in and kind of rely on the PCB pins on the switch to align everything. That's a fine way of doing it. The way I had intuited you would do this, and the way some people recommend doing this, is using a pair of tweezers to install the sockets in place. You can do it with your fingers. I tested a couple with my fingers, and it's certainly much easier to achieve the dexterity you need with a pair of tweezers. You place them in, and then you tape them down. Some people recommend electrical tape. I don't like electrical tape for this kind of application. I like Kapton tape, which is this kind of amber colored stuff. It is significantly more expensive than electrical tape, but it's not quite as, well, it's not as tacky, first of all. And I worry, well, actually the tackiness ties into that, I guess. I worry less about damaging the PCB if I use Kapton tape instead of electrical tape. So you insert them into the board with the tweezers, tape them down, flip the board over, solder them in, rinse and repeat. 130-ish times approximately. I think my layout is 125 switches, because you can split quite a bit on here. This PCB, let me hold my hand up behind the hole so you can see them through the black PCB. It is absolute Swiss cheese on this end of the board, because you can split parts of the numpad, you can split shifts and returns, and it supports ISO and all that. And then the bottom row is just an absolute, it just looks like someone took a hole punch to a sheet of FR4, because you can split the spacebar. There's different bottom row layouts you can use even within the same spacebar layout. There's really quite a bit going on. So I think my layout is like 125 switches, somewhere in there. Yeah, so I'm going to do that method, where you drop them in, use tape to hold them down, flip and solder. Something someone recommended on Reddit that I thought was smart was suspending the PCB so that they kind of drop into place. So I have these little bits of foam that, if you have a Pelican case, you'll recognize this is the pick and pluck foam that goes in Pelican cases. So I'm going to support just the very edges of the PCB and kind of, take this on in chunks. Now, this suspension allows me to drop the sockets into these spots and know that there's nothing pushing them up slightly, because you want that little flared collar on the top of these to be completely flush with the top of the PCB. You don't want any air gap between the two. or your switch will be crooked, which is why some people espouse the practice of socketing them onto a switch and soldering it that way. And I'm certainly open to doing that. I'm going to start with the drop-in tape method, but I do have some burner switches, if you will, that I could use as sacrificial switches if I need to do the switch method. So, I'm probably just going to film it just like this. I may crop in editing. This is just, it's going to be hard to see, which is why I really think this is going to be mostly time-lapse. Like, I can zoom way in, but then I need to move the PCB constantly for you to see what's going on. Whereas if I do this, I can just crop in and edit it. Well, I suppose I could creep in just a little bit. Still get everything in frame. I can crop in and post if something interesting is happening in a particular part of the board. I don't need to be worried about my camera missing it because I zoomed way in and me not putting something in frame, because that never happens. I never do that. Doesn't sound like me at all. So, also, lovely parts tray from Key Cult. Their hex part trays are just fantastic with the 2-chamber design, and I've got one of the hammered silver ones over on my actual desk on my workbench. These are lovely for holding components. I've got my SD cards for my cameras when I'm not using them in the one on my desk. They're very nice, and the hard black ano is quite industrial looking. I quite like it. So, I'm gonna pick one of these up. It's home. And this is the least riveting YouTube video that's ever been created. Oh god. Okay, that's why you order extra Milmax sockets. Because I just pinched a little too hard with the tweezer and thus launched the socket out of my tweezer as well. My robot vacuum, I'm sure we'll enjoy picking that up later if I can't find it here. You know what? This is actually now the most boring YouTube video ever. Man dictates looking for something off screen. Really just primo content. Yep, no, we're gonna call that one gone. That Milmax socket just doesn't exist anymore, and that's okay. I ordered some amount of extra. I forget how many. I should maybe look at that so I know what my margin of error is here. But this is pretty much it. Is picking them up, making sure you have it in the right orientation, and slotting it in. So I've got those 3 there done, so you can kind of see the difference how they look. That collar along the top of the cylinder is short enough that the switch will still sit flush on the PCB. Switches don't actually sit quite flush. They've got little legs under them, and this collar is just short enough to fit under there. And then when you look at the various different sizes of Milmax socket, typically the things that change are the dimensions of that collar and how long the cylinder is. The longer the cylinder is, the easier it is to solder, because you've got more of a wall sticking out the other side of the PCB to wick solder onto, and it's just easier to handle than the itty-bitty ones. I went with the maximum hard mode ones. I think they're 7305s if memory serves. I put it on screen earlier. If they're not, in fact, not 7305s. Okay, now did that stay on the PCB? Did it fall below? It fell below. There it is. These are the ones with the smallest diameter and height, I think, top collar, and shortest overall length. In this scenario, I probably could have gone with the longer length ones because there's quite a bit of airspace under the PCB, at least in the 3D printed version of the Boston. But go for broke. You know, I'm a pretty competent solderer person, and so I figured I'd go for it. So what I've gotten here is I've gotten these 4 done. I'm just going to do a very small batch here because I really hope I just time-lapse the rest of this, and that there's not something that happens so interesting that I have to stop and explain what's happening every 5 minutes, because I'd really like this to go quietly. Calmly, not quietly necessarily, calmly. So now what I'm doing is I'm just taking a piece of that Kapton tape. I'm really pushing down around the sockets just to make sure they are completely flush with the top of the PCB. And now with that tape, I can flip these over. Yep, cool. And so now this I will hold up for you to try and see. Come on, camera. I know it's interesting stuff down there, but focus up here. There we go. You can see just a little bit of those sockets sticking out of the bottom of the PCB. Wow, that looks very small on the camera. It looks not that horrifying in person. But now, yeah, those are holding tight. But now what one does is instead of soldering the leg of a switch, you're soldering the outer shell of the Mil-Max socket to the pad on the PCB. The reason some people prefer the longer length of these as well is that it's less likely that you're going to get excess solder in to the inner part of the socket. Just tinning my solder tip here. Which, if you do it the way where you have a switch socketed while you do this, you're going to end up soldering the switch into the hot swap or into the Mil-Max socket. Whereas if you do it the way I'm doing it and you do that, you just kind of ruin a socket and it's less work to get the switch out of there. So I'm going to try soldering the first one of these. So I'm just going to heat up the outer edge and sneak up alongside with some solder. Looks pretty darn good. I think that technique is going to be fine. Heating up the edge, sneaking my solder along in the side. Now that time I got a little much, sorry, that's just absolutely hair cam, isn't it? I got a little much solder on that one, but I don't see any of it in the socket. So, oh, and it is 4:34 when I'm starting this. I want to keep track of how long it takes to solder these. Whoop, and see, I pushed down on the socket that time. So I'm going to do here real quick. So I'm going to make sure I didn't actually push it proud of the PCB. It does not appear I did. It appears my Kapton tape is doing its thing. So I'm heating up the pad and the socket. Pad and the socket. It's kind of startling actually how much less solder you use on these than you do normal switches. Well, I could be wrong. I feel like I use way more solder when I do. Oh, see, now that one I think I just totally flooded that with solder. I saw that go up and over the edge. So I'm just gonna reflow all these real quick. Make sure our heating was even. None of these look like they're reflowing a whole bunch, so I think my technique was pretty good, but I want to check that one on the end here. Getting solder in these doesn't actually necessarily kill the socket. It's mostly a problem when you're doing it with a switch in there. Because you can get a little bit of solder on the fins, fangs, teeth, whatever, on the inside of the socket. And it's really not that big of a deal, as long as those fangs still move. So I've got just some milky yellow switches that I plan on using here, although I'm seeing solder on the top side of the socket, so I think I probably screwed that one up. Oh, no, it still punches through. So there you go, I'm gonna zoom in all the way here, see if I can show that to the best of my abilities. So you can see the copper legs of the switch sticking out of those two silver spots right by the tip of my index finger. There. You can see the bottom of the switch. The switch is sitting flushly on the PCB. It's actually sitting high on the opposite side from the sockets. There we go. Now the switch is sitting flushly on the PCB. Yeah, man. And does that come out? It does come out. I'm not seeing any like heinous scratching on the leg of the one I flooded a little bit. Yeah, it just punches in there. It does go easier into the other sockets. That's not surprising. But I don't appear to have gotten so much solder in that first one that it will be dysfunctional. Yeah. All right, so that is 4 down, 120-ish to go. It is worth noting that I will have to make my layout decisions now. This means, as of right this moment, I'm planning on stepped caps, standard left shift, 3 switches over. I was gonna pull up the documentation because I already forgot. Boston instructions. They've got a lovely set of PDF instructions for this board, though, and especially with how complex the build process for this one is. You actually solder mechanical components on this one, which is interesting. I imagine the non-3D printed versions of this that they hope to run in the future will be less complex. Okay, there we go. So I plan on doing stepped caps, non-split left shift, 3 1.5U modifiers, 6.25U spacebar, 3 1U modifiers. I might change my mind on that. That's the one I'm most iffy on, but I think I'll probably go with that. That's my most typical, comfortable layout. Standard ISO return, standard pipe, standard backspace, not splitting backspace. I split backspace on 60 on my mode 65, and I use that quite a bit, but since I have a physical escape key on this, I really don't see the necessity for that. I also may change my mind on that. Then the other splits are splitting the 0 on the numpad to 0 and 00. I'm not going to do that. Standard enter, and then you can also split this to be plus and equal, I think, instead of just plus. I'm just going to go plus standard numpad. I'm not a big numpad user, so I'm just going to go with standard on that. But the benefit of doing this as mil-max is if I change my mind on any of this, I can de-socket my switches, go in and really easily change where I have my mil-max sockets. So none of this is terribly permanent. However, this is not a keyboard I want to be frequently disassembling, as it takes a bit of work to get there. So I'm just going to go for it at this point. I'm going to put on a little YouTube in the background, got some videos queued up. I'm just going to have a little solder party here. I guess officially we'll have the start time be 4:40 instead of 4:30 for the start time. We'll just round a little bit for getting these 4 done. I'm very curious to see how long this will take. Recording this preamble, I've just looked at the camera. I've been recording for 22 minutes. Some of that was a false start. So we're a good chunk into the just shy of 3 hours I have on my SD cards. So I'm really hoping I have this done in like 2 hours. That'd be fantastic news. But start time, 4:40. We will see what happens, and if anything interesting occurs, I will interrupt the time lapse. But I hope nothing interesting happens, and it's just a big time lapse that, you know, in the end will be mere seconds of footage for you, but will be hours of my life, because that is how video production works. See you when I see you. Okay, I've just done my third batch, if you will. Really messed up one of these. Got quite a bit of solder in it. What I found worked was heating up the socket while trying to push a switch in, and that kind of got the errant solder out of the way, and seems to be fine. Of course, I have to test all these later, and we'll see how that goes. What I've learned so far is applying the solder very slowly. With soldering on normal switches, you can just kind of, you know, put your solder iron against the leg of the switch and on the pad, heat up both, and just, you know, really kind of just poke your solder in there. With these, I find the best way to keep solder from getting into them is slowly applying the solder. So it's sort of like if this is, you know, the round part of the Mil-Max socket on the other side, it kind of wicks its way around the outside. If you just really jam the solder into one place quite quickly, you get a bulb forming, and then that bulb goes up over the edge and it goes into the interior of the socket. Whereas if you do it slowly, again, the heat wicks it around the edge and you get a much more even flow of the solder onto the socket. So back at it, that also took a little over a minute per socket. So onward. All right, I just got the first F row and the escape key done. So on the 13 switches, again, about a minute a switch. So we're making good time here. This was the first batch where all 13, or the whole batch, rather, not all of them were batches of 13. But anyway, where all of the sockets worked well right off the bat. So I think I kind of got my technique down here. I'm glad I experimented on the F rows because they are keys that are pressed less often. So if I made any mistakes, I'd rather it not be on like the alpha keys, which are hit constantly. So I'm gonna stop pausing between every section to update y'all unless something happens. I think next up here, I'm gonna get a little bit more practice on the numpad, and then I'll go over to the alpha keys and get cracking with that. So if all goes well, this will be the last pause in the time lapse. If something goes terribly wrong, this will not be the last pause in the time lapse. Or I guess if something interesting happens. You know, maybe not something terrible, but something interesting might occur. So, see you when I see ya. Quick bit of excitement. The numpad went great. I accidentally flicked the edge of the PCB and a bunch of the sockets flew out, which was stupid of me, but they all went in. That was great. On the number 2 key here, I completely flooded the back of one of these sockets. I believe it's the right one as you're looking at it there on the number 2. But I did my trick where I pushed in the switch and heated it at the same time, and that seems to have worked perfectly. The switch comes in and out now without any issues. So still cooking along here, onward and upward. Alrighty, y'all, it happened. I completely flooded 2 of these, and so we're going to need to desolder them. If desoldering goes expected and that works, I probably will end recording this session here, because I can't imagine anything else more interesting than, you know, doing my first couple, learning that, getting my technique down with the slow solder, and then finally actually having to desolder one entirely. I don't think there's going to be anything else more interesting than that, so I'm going to stop recording and stop generating more data for myself to deal with. I'll resume recording if something interesting occurs. I'm just waiting for my desolder gun to heat up here. I think we're all set. Now, I've never actually used this on something this large, so we're just gonna go for it and see what happens. I think there's actually 3 of them. 2 of them I really messed up. Actually, here, let me show you before I attempt to desolder. The bottom right switch and the one just to the left of it, control and win. Control, I flooded both of them. I don't know why, but I did, and when I flooded one of them, I couldn't tell you looking through my camera monitor which one it is. But, yep, whoops. So, when I've used this for desoldering a keyboard, the hole in the tip fits over the leg of the... it's not focusing. I'm not going to put my hand near that to trigger the autofocus, but just trust me, there's a hole in the tip. Is big enough to fit over the leg of a switch. It's not big enough to fit over these, so I'm just going to try attacking it from the side here. Just heat up, pull the vacuum, and see what happens. Okay, that actually looks like it worked pretty well. Okay. I think it's this one on the win that's no good. Okay, now put Put that back on its stand. Do these fall out now? I've never desoldered a component just like this before. No, they do not want to just fall out. Let me hit them with a little more vacuum action here. Oop. Hit them from the other side, see how that does. They are not wanting to come out. However, there's a lot less solder in them now. I wonder if that... Okay, so that one's sitting flush. This is the half problematic one. Ow. Poked myself with the little legs. No, I think I just crumpled the leg on the flooded socket. I sure did. Okay, so that did not completely function as I would have loved it to. So we're gonna break out a little solder wick here, which I believe is in my top drawer. Yes, it is. Enough solder off of this thing to get it to come out. Try to make sure my head's not in the way. Okay, we worked off a good bit of solder there. Will you come out? No, you will not. Boy, howdy. Did my desolder gun come with bigger tips? If it did, I do not have them, so I don't think it did. What I'm willing to bet is that there's solder under the collar on this side. Yeah, there almost certainly is. So, how do I'm thinking what I might need to do here is heat and press against these. So I'm going to use some of my chunkier tip tweezers here to put pressure, downward pressure on the socket from the back. So I'm trying to like push it out the front of the PCB. Is that in frame? Oh boy, barely. So put downward pressure with a chunky pair of tweezers, and then heat up the socket. Although I may have such a chunky set of tweezers here now that they're absorbing a bunch of the heat we're putting into the socket. Let me re-tin here, see if I've just got port heat transfer. So we are heating the socket. Ah, there we go. Okay, so heating then pushing. That makes sense. Less thermal mass. So I'm going to heat the socket, push the socket, heat the socket, push the socket. Now those didn't push all the way out, but they might be far enough out now that I can pull them from the other side. Oh, but I don't want to lift any pads. Oh boy. We are learning today, folks. Oh, you know what I need to do? Is I need to I've got the PCB pressed against my chest to hold it in this kind of upright position here. I need to not touch the hot part of my soldering iron. While I transfer it to my left hand, thank goodness I'm cross dominant. I need to pull on the socket while I heat it, as not to damage the pad. Or I guess to damage the pad as minimally as possible. Ooh, boy, that is not wanting to hold on to that round head. Or do I, those are warm tweezers in my hand, I just grabbed those with my closed hand. That was stupid. This power lead to this soldering iron is very twisted. There we go. Heating it from the top and pulling it from the top actually might be the move, because that's where the majority of the mechanical contact is now, is on the top. So heat it. Pull it. Nope, I just grabbed the soldering iron tip. That was hilarious. I was like, I got it. Nope, I was just lifting the soldering iron. Okay, let me tin this again. Get the magic smoke. All right, heat the socket. Pull the socket. Nope. I'm using my. I really don't want to melt the end of my tweezers, but I can get it. I can get my tweezers under the head of the socket. Oh, hey-oh! Got him, and it does not look like I lifted the pad. Okay, that's just a fleck of solder. Okay. Whoop. So I'm heating, and I'm pulling. Here we go. Please let that be in frame. Okay, yeah, I can really crop onto that. Oh boy. So I've got, I'll make sure my head's out of the way. I got my tweezers grabbing onto the base, just under the collar of the socket. And I'm pulling up, and I'm touching my iron to the socket to heat the socket. The Milmax socket. That is, I'm just wiggling. Hey, there we go. Comes out. It does not look like I deformed my tweezers. That's great news. I love that. Let me holster my soldering iron here. Let me see if I can clean these holes out a little bit. Yep. So much. Heat that for. There we go. That's better. Okay. So now I'm going to turn off my desoldering gun because that thing gets blazing hot. I'm now going to try refitting those 3 sockets with my hopefully cooled off tweezers. Yes. So grab a socket here. I think there's just a little too much solder inside the hole that the socket does not want to fit through it. How could I handle that situation? Because it's even worse on these two. Okay, let me think here. Is there, so I didn't look at the back, is there solder all over the back of these? Nah, it's pretty even the whole way through the via. A via is a electrical contact that goes through a PCB, if you've never heard that term before. Obviously, it's also a very common piece of software in mechanical keyboard hobby. I'm gonna measure, this might be stupid, but I'm gonna measure the inner diameter of these holes. But a clean one. .37, 1.4, somewhere in there. I'm betting they're supposed to be 1.4, because why would someone call out a 1.37 millimeter hole unless there's a standard I'm not aware of? Now you might be wondering, Ian, why are you doing that? Well, I'm gonna see here. got a drill bit that size. I'm not going to drill the PCB, but I could by hand twist that bit through the holes to clean them up. Unfortunately, my drill bit set is imperial. So what did I say? 1.4 millimeters. 1.4 millimeters, 2 inches. Oh boy, I'm not sure I have one that small. Oh, you know what? I've got my whole Proxon kit too. I'm gonna grab my smallest drill bit and just see if it passes through. Oh wow, this actually might be like exactly the right size. Wow, okay, that actually might do it. Yep, and it bites on this one because there's a little bit of solder in the way. So I'm just gonna spin by hand. I drill it through these. I don't appear to have damaged the walls of the via. That's looking good. This is a 1/16 drill bit for what it's worth. Real keeping score at home. Just trying to reopen these holes. Boy, now that I see what it's like to desolder one of these, I'm going to be a lot more careful on the remaining ones. I don't see any FR4 on the drill bit, only lead. I need to wash my hands promptly. And honestly, maybe I should wash my drill bit too, but for the moment. Let's see if that has sorted us out. Oh, I guess let me check the pads on the back so I make sure I didn't like blow out the back of these. No. No, all three of those look nice and shiny silver on the inside still. A little bit of debris around that one. That might have been blocking my way. Oh my god, it goes in. Now the other two. Wow. You know, sometimes you do something real stupid, but it works, which probably means it's an OSHA violation, but, you know, I'm in my home workshop, so take a hike, OSHA. So now I'm going to press down with my tape. Oh boy, there is debris over here. Oh, hey, I have a shop vac now. Well, a dust buster. When your home workshop is just your dining room with a workbench in it, you don't really need a full-size workbench. I meant to say full-size shop vac is what I meant to say. But it's a Ryobi dust buster that uses the same batteries as my drills. This thing was like $30 for this vacuum because I already had the batteries from my drill and impact driver kit. It's over $30. I got a little vacuum that I can vacuum up stupid stuff with, like lead. Shh! Don't tell anybody. You know when you're proud of something, they say it out loud and it sounds real stupid. Yeah, that was one of those. Anyway, let me try this again here. So we're going to 10-hour tip because it got oxidized while it was waiting for me. I need to break out the proper tip tinner here. It's been a minute since I used that. Now I need to remember which one it was. It was this one. So nice and slow. Don't get any in it. Nice and slow. Around the edge. Nice. Nice and slow. Around the edge. Nice. Okay. Tape off of there. Have I abused this switch? I have abused this switch. I'm glad I'm using sacrificial switches while I learn this. Because I have definitely mangled some of these while I've been working through it. So again, our control one. We know this one's good. The legs are really tight in this PCB, which is nice. You want steady switches, but it's tight. Okay, this one that was half screwed up. Oh man, right in. I can see both switch legs, that's great. And this is the one I totally borked. And both came through the bottom. Alrighty, well, I think I'm gonna stop recording the process here because I don't think it's gonna get, or rather I should say, I hope it doesn't get much more interesting than that. So I'm going to, yeah, cut it here. If there's a clip of me soldering after this, something has gone horribly wrong in a very interesting fashion. What I've got left is the alpha cluster here, the arrows, and the tiny little nav cluster. Function rows, num row, number pad rather, num row, and these modifiers are done. I did these ones so I could put my styrofoam blocks, or foam blocks, under the full length and basically just load up the rest of these now that I'm comfortable with the process. So I'm going to, well, let me see, how much do I have left on the card? I've got 42 minutes left on my SD card. You know what, I'm gonna keep recording. We'll see what happens. There you go. But I really intend on delivering no further commentary on this process at this point. So, see ya when I see ya. All right, and one marathon session later, I have soldered all of them. I think I messed up 2 that I'm going to go back and recheck, but we started at 4:40, and now 7:01. So a little over 2 hours. If I hadn't really screwed up those couple, it probably would have gone a little bit faster, but that's all part of the learning process. So not too mad about that, and I feel very accomplished looking at this now. This is a PCB that wasn't hot swap when I started and is hot swap now, except for the 2 that I need to check. But that's my problem, not yours. So there you go. That concludes this part of the video that I don't know where in the rest of the video it will go. This could be the beginning of the video. It could be in the middle of the video, but regardless, I will turn you over to future Ian because I'm past Ian. So back to future Ian with the remainder of building the Boston 120% keyboard. Again, the 3D printed version from rndkbd.com. And we're back with the PCB that you just watched me solder, and this video is totally temporally accurate. Yay, time. Get that out of the way. And we're gonna get to the actual build guide here. Step 1 is 3D printing the parts. Obviously taken care of. We don't need to worry about that, but it does have the steps on how to lay out the parts optimally for seams and that kind of thing. Part 2 of the guide is soldering in the PEM nuts. So, but again, already done. I did some of the prep work here. The first step we're actually gonna be participating in on video here today. Well, I guess you just watched the PCB get soldered. Time is hard. Is attaching and aligning those key separator parts. So, like I said, already read through the guide. Still kind of going to be rereading it here as we go to make sure I do everything right, because it's not like I can just, whip out a set of replacement parts, or it's not like a mode keyboard where they keep extras in stock or anything like that. If I mess anything up, it will turn into a support request. I would like to avoid those. The guide is very specific to say you do absolutely need to attach these before you solder in switches. So if you're following along at home, don't think you can come back to this part. You need to do this part now, and make sure that you get everything all aligned and tight. So grab the 3D printed key separators, and okay, so these are the self-tapping screws. I thought my memory was right there, so I'm gonna grab those. Totally miss. Okay, good job, Ian. Not on camera in front of an international audience or anything. NBD. And I'm assuming these are going to be T6 drive. Their heads do not look large enough to be T10. T6 indeed. Cool. So T6 key. as well. Attach the key separators to the plate using the M2x5 self-tapping screws. Use a T6, make sure the screws go in straight. Leave them about a half turn loose, as we'll need to align. Yep, and we're used to doing that on this channel, tightening something up and then backing off just a little bit. So there are 6 screws here, 8 screws here. I'm going to do the left one first. On the ends of these pieces, you might be able to see, the left one has a little nubbin and the right one has a little reverse nubbin, so that they kind of sit together and support each other once they're in place. So I'm going to do this one first. And so there should be 6 positions. So you have 1 up here, 1 up here, 1 up here, and 3 along the main piece. So we'll make sure we get 6 screws actually in there. I figure we'll start right here, eh? So now the reason you're using self-tapping screws here is you really don't need to screw those in far at all. Is because obviously with the 3D print, you're just printing a cylindrical hole in the plastic, and then a self-tapping screw, I think are pretty similar in concept to wood screws. They're almost like a little drill bit in and of themselves, and their threads are sharp, so they just kind of cut their way into the plastic. You can't use self-tapping screws on all materials because not all materials are soft enough to be self-tapped. I cannot talk today. This is a bad day to be recording a video. And so they cut their way into whatever you're screwing into, assuming of course the material you're screwing into is soft enough. So we've got it finger tight, and we're gonna back off about a half turn. I did the same for that one already. So I got my 2 opposing corners in to align the part. Yeah, we're gonna screw that one in and back off. I think this is a very clever way of doing this, so you don't have to have a whole key web on the top case. You just have, it's kind of slipping out of that screw a little bit. You just have these key webs where they're necessary. I think that's pretty clever. Probably makes these parts a lot easier to print. 3D printing a key web, there'd pretty much be no good orientation to print this in, so attaching it to the plate is quite wise, I think. Really slippy. Are these actually hex head or Torx head? No, these are hex head. Why the heck is he telling me to use Torx? That's funny. I mean, technically you can use Torx heads on hex heads, but they slip, as we just witnessed. Okay, and that kind of, does that wiggle? Nope, one of these is too tight. That piece is not free enough to wiggle. I'm just gonna back these all off a little bit more. There we go. Okay, so now that's free to wiggle. And then we're going to put in this one in place and flip it. This one's got 8 positions. 8 positions. 1, 2, 3, 4, 5, 6, 7, 8. Cool. And yeah, at least at cursory glance, those are pretty much aligned. There's further alignment steps we'll follow here. I'm going to time lapse through finish screwing these in. So now it wants us to slide the case on and then screw the plate into the case so we can kind of check our gaps. That makes sense. Let me put away my extra self-tapping screw here. It's predetermined baggy. It's nice that always nice when a kit includes an extra of things because stuff goes missing and it's annoying. Which screws do we use to, the M3x10s are what we use to screw the plate on. M3x6, M3x10, so this is what's partially rainbow. So my assumption then would be is that the top facing ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep, so these are the top facing ones. M3 by 10, 5, and then times 4. Yep. So let me grab my case halves. This will actually be my first time seeing roughly at least the actual form of this keyboard, which is pretty cool. So there's a slot very near the top edge of the case there, and that's what holds the PCB. You can see it on the other side there as well. So we're going to slide our PCB in there, slide our PCB in there. Excellent. And then to do it to the right half, because the way the arrow keys are a little separated, you need to manually spread out the case just a little bit, not much. There we go. Oh, so I loosened some of my self-tapping screws too much because they just fell out. I'm just gonna leave them under there for the moment. I'm gonna get screwed into the plate here. These are also hex head. Why are they so insistent on the Torx drivers? These are all hex head so far. I'm not mad about it, it's just a weird inconsistency. Okay. Yeah, that rainbow hardware looks real nice on the glitter black. I think that was a good decision. So now I'm gonna screw the rest of these in. And we've got those screwed in. So now the way it wants me to go about this, adjust the separator pieces so the gaps between the separators and case halves are minimal. When the place is slid at the very end of the case halves, there may be a small gap. So they expect there to be a small gap right here, where that kind of little nubbin was, which is probably why that nubbin is there, so no visible light comes through that gap. Yeah, that one right in the middle there. And it seems like they have a bigger focus on more of these. Man, I really over-loosened these. Oh boy, glad I'm catching them at least. The guide seems more worried about the other gaps, which actually look pretty good already, if I'm being honest. Oh, that looks pretty well in place. So let me tighten up here. This is kind of our first look at how big it is, fully assembled and holding it. It weighs nothing in its current form. The PCB will add a decent chunk of weight, and then of course the switches and keycaps will. But that's pretty handy. Oh, let me grab the bottom plate here, so we can look at how that. Oh man, that fits in there so nice. That's great. I think it's a very handsome proportional side profile. Nice accent on the bottom. That's great. I think that is very cool. This is a very black keyboard, and it is very hard to film it. Oh boy. Okay, so now next up is taking it out of the chassis again, and tightening up the remainder of the screws. So I'm gonna do that next. Alright, so we'll put those screws back. Probably won't see them again until final assembly, so done with those for the moment. Next up is PCB Prep, so we're gonna get this out of the way. So the way you see this right now is how it comes other than the Mil-Max sockets. So at least for this kit, like the power LED, come on camera, there we go. The power LED right by my index finger there was already soldered in. All your diodes and controllers and what have you. All I did was Mil-Max sockets so far. Very wisely, first step in the PCB chapter is what? What is it, audience? Test your PCB. Always test it. Test it, test it, test it. Test your PCB. There are a couple things we still have to solder that I did not do while I did the Mil-Max, honestly, because I was really tired of soldering by the time I was done with those. I thought I should do at least a little bit of soldering on video here. The first thing is the resistors for our LEDs. So there's our LEDs, and here's our resistors. I'm gonna be a bad boy and not solder at the solder station with the fume extractor, just because it's, you know, 6 joints and I think 5 joints on the rotary encoder. So I'm not terribly concerned about that very small amount of soldering. Yell at me in the comments if you're mad about it. No need to check to make sure these are the right resistors, because you only get one kind of resistor with this kit. I'm just looking at the picture and verifying anyway. Yep, we do have the correct value here. And then there are, I'm going to point at them down here and then hold it up to the camera. Right above my fingertips, there are 3 positions where you solder in the resistors for those LEDs. Given that everything else is soldered in here, I don't know why those weren't, to be completely honest. I mean, I guess all of this is surface mount. Well, this LED isn't surface mount. I could not tell you why these don't come soldered in already, but they don't, and that's fine. So I'm just going to, hand bend these. You don't see them after the fact, and there's only 3 of them. If I was doing a, you know, a whole assembly line process here, I might pull out a diode bender or a guide to use, but we are doing a very small number of components here. So we've got number 1 in place, and then once you've got your legs through, splay the legs out to hold the component in place. Resistors are not orientation dependent, so you don't need to worry about having these the right direction. The LEDs, however, we certainly will. The D in LED stands for diode, so you absolutely need to have those facing the right way. The resistors, you are free to orient them as you please. Current will happily flow either direction through them. I'm just I'm looking to make sure I have all mine the same way. Doesn't matter which way, but you know, as long as I'm doing this, I'm gonna do it right and make sure they're all facing the same way, at least. Excellent. Lay those legs out. Now, is it gonna have me solder those and then do the LEDs? No. Okay, LEDs are next. So we are going to need not only our LEDs, but our little 3D printed guide. Okay, grab the spacer for the LEDs and thread the LED legs through it. So we want, okay, so the main purpose this is serving here, these little pins that are sticking up, the LEDs actually stand atop those pointing towards the user. So they're taller and probably just sticking out the top of the keyboard. That's why this piece exists. And spacer only fits one way, so I guess you can't, yeah, so it goes over one of the resistors, and then that little notch, like I said, is so it kind of hugs another one. So can't put that in the wrong way. That's great, you love to see it. And then the longer leg on LEDs is the positive side, which is critical in this PCB. The positive terminal is on the left side, so I'm gonna put the longer leg on the left side. I'm now gonna warm up my soldering iron because I just realized that it's off. I do have it set back to 325. the 480 for the PEM nuts was sufficient, but I don't want to solder LEDs at 480 degrees. That seems a little excessive. So just threading in the last one here. There we go. So you can see the longer leg of the LED is on the left side in each of these cases, and it's kind of sitting atop that little pedestal. And then just gotta get all 6 of these legs to go through the PCB at the same time, which went pretty well. That's great. Why is it not lining up? Oh, because your boy put it on upside down. Okay, flipping all the LEDs. Flipping all the LEDs. Flipping all the LEDs. So the side, I'll put it back through here and then I'll hold it up again. The side with the bite on it faces down, not up, as I showed you a moment ago on camera. Okay, so that's how it actually should look. There we go. So you can see the LEDs are standing tall off the PCB, nests around the resistors, and then on the back we've got our 12 legs sticking out and bent, which is great. I'm just gonna keep scrolling here and make sure there's nothing else. Then the other item is the encoder. The encoder I will also just do during the sure to follow time lapse, because I love a good time lapse. The encoder goes in a single orientation. I don't think you can make that one be backwards here. I'm gonna flip this that way. There we go. One side of the encoder has 3 pins, one side has 2, as you can see right there. So it only goes in one direction, and then these 2 outer pins are ground/structural support. So that will go in above the escape key over here. So I'm going to solder these 12 joints, solder these 7 joints, and then I will be back with you. I'm just going to do that all in a single time lapse. All right, so we've got the last small bits of the soldering done and the PCB prepped. At this point, part 4 begins with installing your stabilizers and switches, or rather is installing your stabilizers and switches, and begins with selecting your layout. Now, the Boston supports a ton of layouts. It does support ISO, so ISO enter and split left shift. It supports split backspace. To the right of spacebar, you can either have 3 1U modifiers or 2 1.5U modifiers. I've gone for 3 1U modifiers. You can either do a 6.25, a 7U, or a split spacebar. I've gone with 6.25U. Same thing on this side of the spacebar. You can either do with 7U, 2 1.5U mods, or if you do the 6.25U or the split spacebar, you've got 3 1.25U modifier keys here. Again, split shift for ISO, stepped caps or non-stepped caps lock, and then over on the numpad, you can split the 0 into 0 and 00. You can also split the plus key into a plus and a minus key for the alternative numpad layout that has a couple more key options. I have selected stepped caps, non-split shift, 3 1.25U modifiers, 6.25U spacebar, 3 1U modifiers, standard ANSI enter, backslash, and full-size backspace. I do like split back from a typing standpoint, but in this scenario, I don't know what I'd put in the split back position because I've actually got my tilde key and I've got my escape key and 2 goddamn function rows. That's what I'm going with. And then full-size 0 and full-size plus on the numpad. That's just the standard layout. I rarely use a numpad as is, so I figure it goes middle of the road as possible. Next up is installing my stabilizers. So I'm going to pop one into place here, just as a reminder of how it's done if it's your first time watching a keyboard build. PCB mount stabilizers, the side with the wire closer to the bottom of my hand clips into the PCB. This top side will either screw or clip in depending on the style of stabilizer. On the PCB around a stabilized key, there's a pair of big holes, which my finger's under right now, those 2 down there, and a pair of small holes up here. The big holes are for the clip side, so the wire side in this case, wire side down. Bottom clips in, the top will either screw in or snap in, and there you go. You want to make sure your stabilizers are nice and flush. You want to make sure you lube them before this point and balance the wires if you're going to. So I'm going to next install all of my 7 stabilizers in this case. All right, all 7 stabilizers installed and tested. Things are sounding and working well. So at this point, it is time to snap in the rest of our switches here. So on the top side of the plate, but it'll be hidden under the chin once you assemble this board. Trying to get it in frame without crashing into my display. There we go. You can see that there's actually a little guide on the bottom of the plate here to make sure you get all your switches in the right place. And the build guide actually recommends that you start with the bottom row, so that you don't accidentally end up in a situation where you've messed up. The guide also assumes you're soldering everything in. I'm in a situation where I'm hot swapping, so I've already made all those decisions, soldered everything into the correct places, or God, I hope so. So we're gonna drop that in place. And we're gonna grab our thick box of Zakus here. I'm going to clip the first one in here. Make sure that the switch is snapped into the plate, which it appears to be. That's great. And I'm going to do one in the opposite corner, which feels like a bajillion miles away on this board. I'm going to use the decimal on the numpad because it's a one-use spot, so there's no wiggle room around it. And honestly, I think I'm gonna do the other corners here too. Give this plate a little bit of a support here. Yep, pull it up so I know everything's snapped in. We're looking in pretty good shape here. Okay, so I'm going to go ahead and snap all my switches in. At this point, it is going to be a number of them. And it's interesting. Again, this is my first time with the Mil-Maxed PCB. It's interesting how the insertion force feels similar to a KL hot swap socket. Like it really does seem to be a pretty good analog for having a KL or, you know, those style of hot swap sockets. I think there's a couple brands of them now. KL was the main one, at least when I got started in this hobby. So I'm going to snap in 130 switches or so here now, and then I'm going to test the PCB once again. So enjoy the following time lapse of me snapping in a bunch of switches. All right, all but one switch worked. How about that? Number 4 here, I looked at the socket on the back, and it's there's a little bit of solder in the socket. So what I'm gonna do is, I found this worked well. Y'all watch the soldering segment. I'm not sure why I'm explaining it. That's the same video. But anyway, heating up the socket that's a little flooded while you push the switch in seems to sort you out pretty well. So I'm just waiting for my soldering iron to heat up here. I've got my finger pressing on the switch underneath the keyboard here. So once I've got that socket flooded, once I got my soldering iron heated, I can hopefully deflood that socket. Oh yeah, that's much more what I would expect. Okay, there we go. That sounded much better that time. We're gonna plug in here. See if I can type a 4. Oh boy, I can. Boom. All right, that's excellent. Switch is done, so I potentially mangled one switch because I really shoved the leg back into the housing. So we got 9 switches left, so I used 121. Maybe I think I initially was planning on possibly using split backspace and split space, so that's why I think I had 125 in my head. Regardless, I had enough switches, so that's great news. I didn't want to either A, have too few switches, or B, because this is my first time mil-maxing, kill enough switches that I wouldn't have enough extras. But we seem to be in great shape, which you'll love to see it. It's great news. Let me quick check the SD card here. Oh, we got an hour and 10 minutes left on the card. We're doing all right. So yeah, seriously, soldering this thing is going to be the longest part of doing it, but that's all right. I'm going to quick scroll through the rest of the guide here. I think I'm going to do the same thing here that I've been doing for a little while now. Is actually install the keycaps now so that I'm not putting a bunch of pressure on the inside of the chassis unnecessarily. Yeah, the rest of it is assembly and then keycaps. So I'm going to do keycaps now. Make enough room for the tray here. Now, is there actually a reset switch on the back of this? There is not actually a reset switch on the back of this. Okay. there's a spot for one, so I can manually short it if I need to. I just noticed when I was going through the guide about the reset switch, because the firmware situation on this is a little interesting. I don't believe this runs QMK or anything, but I think you can make it run Vial, which is the open source version of VIA. So I'll need to do some tinkering off screen with firmware, and if anything interesting happens, maybe come back and shoot a little addendum to this video. But let's do keycaps. I'm going to work through this. I think I'm just going to end up using a bunch of these like symbols for the F row, and then the actual F keys for the rest of it. Yeah, we're going into another time lapse short version while I figure out what the heck my layout of keycaps is gonna be. So see you on the other side of me figuring this out. All right, this will almost certainly change, but at least to begin with, I'm pretty happy with that key layout. I think that'll function, but it'll probably change. Onward. There are these little pockets inside here where there are these hexagonal cutouts where the hex nuts get pressed in. So let me find those right here. How did they do on the tolerances on these? I can imagine these might need a little bit of work, if anything. No, they fall right in. Excellent. So just while I'm doing this, if there's any change I would make so far to this build process, I put some standoffs between the plate and PCB. You might have seen me in the time-lapse using those plate forks, which made a world of difference. Oh, and this is actually the step where you can use super glue. I just all of a sudden had like one of those like Spidey sense moments where it's like, wait a second, I remembered this step for some reason. Oh, there we go. Some standoffs, I think, between the plate and PCB would help. I used plate forks to hold them apart from each other, and that worked fine. But for general buildability, that might be a nice improvement. This whole project is open source, so I mean, someone could make their own version of the Boston. If you are so inclined, you could go in and make your own modifications to the Boston design if it doesn't do something you want it to do. So who knows? But I think in general, that would be a nice quality of life improvement. I'm just gonna hit these in the corner. Just one of the corners with a dab of super glue. I've talked about this before. I'm actually in night school. The reason I'm able to do a build this lengthy is because I actually have a long weekend. It's Memorial Day here in the US. And in psychology class, my current class, we learned about why smell memories are so strong. It's because the nervous connections between your olfactory bulb, where your smell processing takes place, is actually one of the few parts of the brain that has direct memory access. I'm probably not saying that as eloquently as I could, but if you're ever wondering why, man, every time I smell this, I instantly think of this moment, that's because of your internal wiring. How about that? All right. So next up actually already reinstalled the PCB. Okay, well, that wasn't gone for long. Put our extra nut back in its bag. This bag of fasteners next. We're going to use the key cult tray that has two lobes. Two of these key cult trays are absolutely awesome. I'm a big fan of these because we've got two kinds of screw in this bag. A rainbow one jumped over there, so that'll be the side with the rainbow ones. Fate has decided. All right. So, I can turn my soldering iron off, huh? That's probably a good idea. There we go. All right, so I'm gonna just grab a black stick here and just dab at those. Some of those beads of super glue are a little large. I may just step away here for a moment. It'll be a cut for you, y'all won't notice. and let those dry. It's always so funny to me. I've built, I don't even know how many keyboards at this point, how you're doing all these work on these little parts over here and over there. You're, you know, flip-flopping between what you're working on, and then all of a sudden it's like, it's done. we're just about there with this one. I don't think that went into its channel. There we go. Okay, 1/2. Oh, stomach's grumbling. I need to eat something after this. Install, and then, yeah, so it wants us to leave them a little bit loose again, because I think we need to kind of level the case when we're done, and the tension of these screws kind of dictates some of that. So I'm going to get these screws back in, the rainbow case screws. All right, we got that done. I'm going to flip this over and hope none of those nuts fall. Okay, I didn't hear any fall, so I think we're... Do I see threads in all these? Yes, I do. I think we're in good shape. A little bit of super glue ended up in the threads of that one, but that'll be fine. That'll work out. All right, and now we get to put on our awesome bottom panel. We now need our M3x6 screws, which are these fellas right here. Ta-da. And bottom panel, where did I put the bottom? There it is. There are parts positively everywhere. So we're gonna drop that in place. Excellent. And then how many? Install the M3 screws in the middle 8 holes. So that's gonna be these 8 here, and then those foot brackets I showed you earlier. That's what goes on these outer ones. So let me get those installed. All right, and with those installed, we now get to do our little foot brackets. I'm not exactly certain what purpose these serve. I'm gonna install them, obviously, but I'm not sure. I guess maybe they guide the foot into place. So I guess they create a little bit of a gap to, so maybe the screw heads don't crack. No, I'm about to screw these in. I have no idea why these are here, but oh well. We're given all the parts. We're gonna put all the parts in. This is the screw that had all this super glue over it. Ah, we went in just fine though, no worries. Cool. Oh, see, now these look like Torque's head drive. Ah, I don't understand what's going on. Oh well. Yeah, no, that's skipping. That is Torque's head. I thought some of the other ones were skipping too. These T10. Yes, sir, they are. Weird. So let's not stumble this close to the finish line. Oh boy. All right, and the reason you leave all this loose is in fact for leveling the keyboard. You kind of want to, you'll flip the keyboard over. Well, we'll do this together in a second. Flip the keyboard over, push down in kind of its center of mass, so that it sits flat against the table, and then tighten the top screws. Just anytime you sling 3D printed, and actually, I mean, metal for that matter too, is not immune from this. You might have some torque in one of the parts, where it's just a little twisted, and when you have anything on 4 feet, it'll rock back and forth. That's why camera tripods are tripods with 3 legs, because you can 3 legs will sit evenly on any surface, where as soon as you add a 4th, you're in an over-constrained situation, and you might end up with wobble. So it's nice that there's a step in here to help avoid that. Let's flip her over and see if I have any wobble. I have no wobble. Ha! How about that? That's great. I'm going to assume that's because I put it together very carefully. Yeah, that's it for sure. It's funny, one of the last sentences in the leveling section is actually if you have if there's unresolvable wobble or misalignment, you may need to adjust the frame alignment on your 3D printer. I feel that. This is quite tall. I don't know what I expected. It's a big keyboard. Well, that's funny, it's not a big keyboard. Anyway, let's finish up here. At this point, put on knobs and keycaps, plug into a keyboard and check that it works, and then part 6 is all about the flashing, the firmware, and it does indeed support Vial, so I think that's what I'm gonna go with. I need to put a knob on. I've already done keycaps. And I just used a random smattering of the laser symbols on the keys I'm not sure about yet. I'll get that all figured out with time, I'm sure. So you can really only see the top of the knob, so which one of these looks the nicest? That one's pretty monochrome. This one's got 3 colors visible, so we're gonna go with that one. Get this set screw backed out here. Yeah, how about that? That looks pretty good, eh? I'm happy with that. All right, just looking at my parts bags here. I've just got like the little 1 extras of some things left. I think we're in good shape. There you go, gang. We'll zoom in just a little bit more. There we go. The Boston 120% keyboard. Again, the 3D printed kit from rndkbd.com. I was right, the LEDs come up to just almost peeking out of this piece. That's what that riser is for, is to go through this top kind of facade piece. The power LED is sub-flush, that's not a big deal. Knob, escape, your double function rows, numpad, nav cluster. You know, they looked real spindly when I was putting them in, but those key blockers actually worked quite well to make it look like a very coherent top. That was a very smart manufacturing thing, whoever figured out how to do that to help with the fabrication process. But look at that, huh? It's so opposite to some of my other keyboards. Give me just a second here. So the Boston is a 120% keyboard. This is a 60% keyboard. That is almost the same, not almost the same size, but actually in a pretty similar size class because of the fins. Makes the thermal an extra wide unit of an HHKB, but 60%, 120%. So a lot more keys going on there. But that all said, because of the collapsed nav cluster, my Rama here, U80, which again has chunkier bezels than some TKLs, not all TKLs are the size of the U80, is really not that much narrower than the Boston, and height actually also pretty similar, really. So there you go. That's that. Oh, I want to weigh it, actually. I'm curious how much it weighs. It feels very, very light. My kitchen scale is disgusting. Sorry about that. Blocking the camera view of the scale. 1,256 grams. 2 pounds, 12 ounces, almost 3 pounds. Really not much. really not much. Goes to show when there's no metal involved, how that goes to show there's no metal involved, how all that works out. It's kind of funny. So thanks for hanging out while I built that. This is certainly going to be a long video. This clip is also about 2.5 hours. So yeah, and then lubing, 130 switches. I do them at about 2 minutes a switch, so that means we've got like 4 hours of lubing, an hour of prepping stabs yesterday, 2 hours of soldering, 2 hours of building, or 2.5 hours of soldering, 2.5 hours of building. So that's 5 hours, 6 hours, like a 10-hour build, all in. But pretty cool. It's funny. This is one of those things that I bought, and it's like I'm not honestly sure if I'm going to use it, but I just wanted one in the collection so bad that even if it just ends up being a display piece, that's kind of totally fine with me, especially considering it was a $200 kit because it's 3D printed. I'm sure that the PCB is at least a third the cost of the kit. Yeah. So there you go. There will be a sound test to follow. I'm honestly not sure what I'm going to compare in this one because I'm not sure I have any other keycap sets that'll fill this out. Oh, you know what I could do is I could do DSA milkshake. That could be the comparison point, is different keycaps. Because I've got enough. DSA is uniform profile, so I'll have enough and the right caps to fill this out. So that's probably what we'll do. Watch the sound test. I might do something different. We'll see what future Ian does. But if you got any questions, leave a comment. If you liked the video, please like it. And if you want to see more, subscribe. I make keyboard videos, and it's free. And you can subscribe when you're bored of watching keyboard videos. I understand. It's okay. So, thanks for watching. See you in the next one.